All right, so isopropyl alcohol. I'll just draw out the full structure. Oh, that was a bad idea. Let me do it like this. Let's go with orange. That is because there you go. That's better. So, does anybody know what the other name for isopropyl alcohol is? Yeah, common rubbing alcohol. So it's obviously disinfectant. And when you buy isopropyl alcohol, it doesn't come as 100%. It's going to be some kind of mixture, probably 50-50 or 30-70 or 70-30. Just depends on which version you're buying. But there's no segregation of the water and the isopropyl alcohol because the two things are miscible in each other because they both have hydrogen bonding on them. What is the concentration according to molarity? Okay, so I don't. Say again? Louder.
Me and Eric will step down hydrogen bonding as the reason that oxygen and no, the two hydrogens.
Did you do this?
No, we cannot connect the O to.
Show.
We showed it as hydrogen's bond, not as oxygen.
You showed it as the hydrogens bonding to each other?
Yeah.
That's a problem, right?
Yes.
We're okay with that? Why? All right, good. All right. Just as long as we know. All right, so I've got some potassium iodide, and I got 140 grams of it, 100 milliliters. Molarity. Okay, so 140 grams Ki in 100 milliliters. And it'll be 1,000 milliliters for 1 liter. So milliliters are gone. And then 1 mole Ki, grams Ki. And what do we got? 166 sounds good to me. So I got 140 divided by 166 times 10. So 8.4 molarity. Great. Will this potassium iodide dissolve at 20 degrees? What about at 10 degrees? So how do we answer that question? Look at that graph. So solubility curve. Okay, so here's my solubility curve, and we're looking at 10 degrees. I could get, looks like maybe 135, and then at 20 degrees, maybe 144. All right, so what was my question? It was 140 grams, so yes for the 20 and no for the 10. So you'd be able to dissolve you'd be able to dissolve 135 grams of that, and then 5 grams of it should be sitting at the bottom.
So I was wondering, that my gold is, it said that 140 would dissolve into 3%. Or, yeah, 140% dissolve. That is different because that would be this is the combined volume of the solvent. Is this the combined volume that I'm going to know the final volume, not water?
True. Yeah, because its solution asked you about molarity. So it's more like 97, 90, 96 and a half-ish. We'll just act like it's 100. But I don't know what you Googled, where that came from. There's nothing inherently wrong with Wikipedia, but all right. What was the point of this question? Let's go with that. For you to understand that sometimes you can change the temperature and change the solubility to increase the solubility. So in this case, with the graph that we had, at 10 you can get 135 in, and at 20 you could get 144 in. So it would be, for our purposes, a no for the 10 and a yes for the 20. All right, how about our poor goldfish? As temp increases, actually reminds me, we were watching Finding Nemo, and it was really funny. There was a part where Marlin was up top, out of the water, like looking to see which direction a boat went, and he's like not breathing well, and then he goes into the water and takes a huge gulp of air to come back up, opposite of people. It was just humorous because obviously he's not gulping in air like that. Who's a better electrolyte? The first one? It is the first one. What?
That is the full separation. Full dissociation.
No, I have a full dissociation. Both of these things are soluble. So this is going to turn into this stuff and two of those. This is going to turn into one of those and one of those. So we haven't got to this part of the notes yet, but why would this be a better electrolyte? No, the first one cancels out too, charge-wise. What was it about? What made something an electrolyte? Anions and cations being available, right? What do I have in the first one? In the first one, I have 3 charged particles. In the second one, I have 2 charged particles. You okay with that? So the more charged particles I can get into the solution, the more it can act as an electrolyte. Okay, so colligative properties. What? Don't do that. Change in the pure properties of a liquid when a solute is added. That's a colligative property. And how does the colligative property get affected? How does its liquid state get affected? Gets bigger? Gets bigger? We okay with that? So it freezes at a lower temperature and boils at a higher temperature. So it's literally a liquid over a larger range of temperatures.